Okay, so we've been doing stuff on expectation this week, and one of the things that we have been doing is we've been looking at what happens. Can everyone see that? Okay, should look like a graph with
Yeah.
some dots on it.
Yep.
Okay, so the top slider is what happens when I add numbers. So this is my original set of numbers, and this is the new set of numbers. So if I add a number to them, you can see all those numbers have just moved up the number line. And if I move it to the left, you can see they move to the left on the number line. So this is the whole idea that if I add and subtract, of course the average, which is going to be in the middle here, and the average is going to be in the middle here, is going to move as well. But the range of values is going to stay exactly the same. And if I just grab one of my dots and move it around, it too gets moved, but still the average has moved further south, further down the number line. Or if I'm adding on, further up the number line. And then the other idea was what happens if I multiply? And if I multiply by a number, my data gets more spread out. So therefore, the mean will be bigger, but the range of values, which we measure in this stuff as standard deviation, is much bigger as well. Therefore, my standard deviation should get larger when I multiply. And I think I did this so that I could go negative, but that's not really going to change much. But it might help explain the next thing we're going to talk about. If I multiply by a minus number, my data has got more spread out again, but the multiplying by a minus number does not change the fact that that range has increased. So having a minus number still means we've got a bigger range. Okay? So those were what we've been talking about over the last couple of lessons. Hi, Jacko. One of the cats has just turned up. So what I want to look at now is what happens when I'm adding different distributions together. So when I was adding constants or multiplying constants, we knew that when you added a constant, it added onto the mean. And we knew when we multiplied by a constant, it multiplied the mean. And then when we worked out the standard deviation, if we added on, it didn't change the standard deviation. But if we multiplied, it changed the standard deviation. What I want to talk about is imagine I've got two separate variables. So we use letters normally to indicate our variables. So I've got X and I've got Y. And if I add or subtract those two variables together, when I'm working out my mean, which is all the expectation has ever been, I would either add or subtract those variables together. But when I work with variance, it doesn't matter whether I'm adding or subtracting. I always must add the variances. Now, this is important because in the last couple of years, 2 years ago, I think it was, no, 3 years ago it first happened, then they did it again 2 years ago. They put a question into your NCA exam about adding variances together, and it's the only time since they had this new standard, so since 2015, that that's been in there. Okay? Now, I'd always taught it, but some people have been basing it on the previous year's exams, so they got caught out with that. I was a little bit surprised though, because they used it to test if the two variables were independent. So they gave them the variance of one distribution. They asked them to calculate the variance of the other one. And then in the next question said, show if this is the combined one, are these two independent? And you had to use that formula to show that they were in fact independent. Okay? Everyone okay with that part?
Yeah.
Awesome. So you should have kind of done some questions on that on pages 27 and 26 in the Walker book, but I just wanted to recap and just want to make it clear about that independent test that they have used. We've got two things I actually wanted to talk about today, which are the main reason why we're doing the Google Meet. And the first one is about if we are combining lots of distributions as opposed to multiplying a single distribution. Okay? And the reason why that matters is because if I think about this one, I've got a female in New Zealand who weighs a mean of 4.5 kgs and a standard deviation of 4.5 kgs. 45 kgs, that'd be a massive standard deviation. And a lift can hold up to 8 people. When I come to work out my variance, let's change that. Let's say I've got a new variable for the total weight. That is the variance of 8 individual females. Yeah? Which would be the variance of 8 lots of the variance. So to work that out in terms of the standard deviation, that is 8 lots of the standard deviation. But because we've square rooted the variance to get the standard deviation, I've got to multiply my standard deviation by the square root of 8. Whereas when I'm working out my mean in that case, the expectation of t is the expectation of t plus the expectation of t 8 times. So that is 8 times the expectation of t. Sorry, the expectation of x. Put the wrong letter in there. My mistake. Okay, because I'm adding on those 8 women and they've each got a mean weight of 74.5, assuming my distribution. So therefore I'm allowed to do that. But when I come to do the variance, it's 8 times the variance. Okay, so let me just close all that down. I've been doing D&D books today. So those of you who ordered the D&D books, they got delivered to my house yesterday and I've sorted them all out. So we're almost ready. So as soon as we get down to level 3, I'll be emailing Mr. Davies and asking for permission to invite you in to come and pick them up. Right. So, therefore, the mean and variance or mean and standard deviation for my lift will be 8 lots of my mean, which is 74.5. So the lift mean is 8 times 74.5, which is 596 kgs. whereas my standard deviation of t is going to be the square root of 8 times the standard deviation, which is 4.5, which will be 12.7. Okay. Oops. Clicked on the wrong thing. So that will be me having lots of distributions being combined together. That is different from, I've got a Sparky mate who knows the mean of a job is 10 meters and the standard deviation is 2 meters, and he knows the cost of the cable is $0.50 per meter. So what's the mean and standard deviation of his costs? That is different from this one because the expectation of his cost is 0.5 times the mean. And his variance is the variance of 0.5 times the variance cost. So the difference is going to come out when we actually do the calculations, because that's going to be 0.5 times 10, which is $5. But this one, when I come to take the 0.5 outside my variance, I have to remember to square it. And when I take that out and I square it, then I can get that it's 0.5 times the standard deviation. Which is 0.5 times 2.5. Which is $1.25. And the reason that matters is because if I've got lots of different distributions all being combined, some are going to be bigger and some are going to be smaller, and those are kind of going to average themselves out, which is why my standard deviation gets smaller. So rather than multiplying by the 8, I multiply by the square root of 8. Whereas when I'm multiplying one distribution by a constant, I've got to take into account that, oh, I've made a mistake there. I've got to take into account the fact that I should have, well, no, I haven't. I've got to take into account the fact that that one distribution had the same variability. Suddenly had a moment where I thought I had failed to square root the 0.5, but I'd taken it into account by square rooting the whole thing. So that's why I suddenly thought I'd made a mistake. Okay, so those are your two different cases when we're doing combinations of lots of different distributions, as opposed to multiplying a distribution by an amount or on a cost. Okay, and that's quite a crucial one, because if we were doing one, it wouldn't surprise me if they kind of came up with this idea that a traveller flying on a plane, hopeful, but had a mean weight and a standard deviation weight, and their bag had a mean weight and a standard deviation weight, and how much did the total of a traveller's bag and person travelling mean and weigh, and then if you've got an airplane of 25 people, how much did the whole people and the bags weigh? Those are two very different things. Okay, So you've just got to be aware of those just to make sure you get those covered. I was going to do continuity correction today, but I think I'm going to stop there. So we'll save continuity correction for another day because, we've got time. I'm going to stop the recording and then I'll take any questions.